Hey guys, welcome back to Makeshift. It's Jake. Normally I'm the one behind the camera, but today, unfortunately, you probably noticed that we haven't had a whole lot of uploads in the past month, and that's kind of due to the whole coronavirus COVID-19 situation that's going on right now. Um, and since we're in Minnesota, we have a shelter in place. And so we're really not able to go and work with each other. So we have kind of been just, hanging out at home. I've been working on my own little home projects and things like that. And one of the things that I've been really dreaming about for quite a while and finally kind of got the opportunity to do is I wanted to work on some lithium ion packs, battery packs, it's for like e-bikes and scooters and that kind of stuff. Because my goal is actually to build some sort of kind of a fun adult size large scooter, something that I can ride. I'm 6'4". I'm a pretty big guy, and like I really love riding on the Lift and Bird and all those kind of scooters. But the one thing I hate about them is you hit any kind of a grade, and if you're big, boom, done. You can't go up the hill. And they sell those pretty cheap. You can get them for about $400 online, but I mean, they say they're 500 watt or 700 watt, and I really don't think they are. I mean, they might be, but I don't know. What I'm looking to do is build probably a 48 volt or 52 volt system. Realistically, I think it'd be about a 50.4 volt nominal voltage on that pack. So it should be 14 in series, and then probably doing at least a 4, but possibly 6 parallel. So 14S 6P, I believe, is kind of my rough estimate right now, what I'm working with. And I know this isn't kind of what we've normally been doing with the whole Chevelle stuff. Kind of our idea was just to do all sorts of different automotive type of things. I mean, we're gonna see if we can get out this summer, some ATV riding, working on. I've got a jet ski project. I'm going to be throwing a motor in a jet ski once it gets a little nicer out. I've got some work on one of my ATVs. I got a Scrambler 850 that needs a few repairs that I was probably going to take a look at. So we're going to kind of spice things up a little bit. All right, guys. So right now it's a little hard for me to kind of see everything that you can see, but hopefully it's coming out all right. So kind of this is just my setup I got going right now. I've got some chargers back here. I got some Opus BT C3100s. These here right now are running some tests on these batteries right here. Basically what these are, they're Samsung. Let's see if I can get this to focus. There we go. And so they're Samsung ICR 18650-26F. Basically they're 2600 milliamp hour Samsungs. Haven't quite looked at the spec sheet on these, but I mean, they're probably at least 2 or 3C at a minimum. And at 2600 milliamp hour, that should be pretty good. Especially because I don't think I'm going to have to draw that many amps out of them. So I've got these. They're kind of just a whole bunch of different, they're all reclaimed from these Eris packs. and these Aris modem backup packs. So here's this one. These ones here, it says 2400 milliamp hour. So these ones are series, 8.4 volt. So there's 2 batteries in these. There's 4 in these, and so these are 8.4, but they're at 4400. So these are even smaller. You know, they're so that kind of sucks. But got some of these, and I got these still in the pack. These are the same exact specs, 8.4 with 4400 milliamp hour. So again, there's 4 batteries in here. Shouldn't even show you guys these, because these are kind of the granddaddy ultimate good ones. These are what all these pink ones came from. And these are 8.4 volt at 2600, and comes with 2. So hopefully that came out. There we go. So yeah, and then I was just gonna mess around because I've never really made a battery pack before, and so I've just got this cheap 13 cell 10 cell 20 amp, yeah, 10 so it does 10 cells at 20 amp. So this would be for like a, you know, kind of like a 36 volt nominal battery pack. So what is that, like somewhere around 42 volts, I think, fully charged, somewhere around there. But yeah, so this is gonna be for a smaller kind of little e-bike. This is a real cheap one. But I don't know what I'm gonna do with this. I kind of might just take some of these smaller ones and just build kind of a small fun pack, just for, I don't know, some sort of booster pack or something like that, just for this summer, hopefully when I can go camping. What these are doing, basically when you reclaim these batteries, you want to throw them on some sort of tester charger. And so what these are doing is they're all these batteries are charged, and then throw them on there. These make sure that they are all the way up to the 4.2 volts, and then they start a discharge process. And they start discharging these all the way down to, I believe it's somewhere under 3 volts. It says 2.8 in the manual. And it gets there really quickly, though. Like after 3, it just falls off a cliff. So it drops, and then it'll immediately start to charge them back up. And then what it does, it'll tell you the calculated milliamp hours of the battery. So basically it took it all the way down, and then it put it all the way back up, and then, you know, it's kind of like doing an MPG check on your car. You know, you took it all the way down in gas, now you topped it up. So that's what you're doing. And then so the idea behind that is you want to know what each one of these gets, because just like every single car out there, everyone gets slightly different gas mileage. Even if the same person drove it or a computer drove it, every motor is going to be slightly, the efficiencies are going to be different between them all, right? And that's the same thing with these. Just a slight difference in chemistry and how they were used and that kind of stuff, you know, because they're kind of just all mixed at this point. So then what you do is you check for all that, and you figure out the milliamp hour or the capacity on them, and you can build a more balanced pack. And so there's some really handy solar pack, like solar wall calculators that you can look at online that actually will help you calculate all this stuff. So you input all the different cells that you have, and it'll tell you how to arrange your pack to make the most optimum pack. I wanted to show you how I've been opening up like these packs here. So I won't show you the 2-cell ones because those things are super simple. This is a 4-cell pack, and so these things are not too terribly hard to get open. I've watched some stuff, and I mean I've definitely torn apart my fair share of things, and so breaking into a plastic shell isn't very hard. So I'll show you the tool I built. It's not too crazy, but basically it's a just a Harbor Freight cheap little vise that I have around the house for just doing little projects that just kind of floats around. I did mount it on a base so I don't wreck my my table here, and the base is basically just a board, and then I put some cork on the bottom, and then all the bolts are just ran up through. And then this looks like it's a soft job kind of setup, but it's not. What I did was I actually took some bolts like this, and if you see this head is actually sticking off the side here and here, and so basically I just put that in there and then taped it on really, really well. And you can kind of see, come on, focus. There you go. You can see that it's really worn right here, and it's because I've been using it a lot. And basically the idea behind this is, you know, there's a nice gap there, and then these are hard, and so I'm trying to put stress here on the seam of this and kind of just split it open like a not sharp can opener. And I'll show you how it works. It's going pretty good. Also, don't forget safety glasses, because I mean you are working with plastic and you're breaking it apart, and look at all those little batteries. So just gonna show you kind of how opening one of these goes. So you take it, you have to slice these labels or it won't split open. And then basically I just start here and get it kind of centered up, kind of put it in just like this, centered up, and you don't have to go very far. You're just going to kind of smush the case just a little bit, because it's just you know, they're just welded seams. And then once you get it on one of these flat parts and you screw it in just a little bit, you can kind of give it a push, and it's kind of like if you've ever used like a pipe cutter, something like that. And so that's kind of the idea. You kind of work it a little bit, push it, pull it, and you're just kind of just trying to work the seam and crack it. And then when you get up on this connector piece here, I just try to get up right on this edge, because it's a lot stronger, and then kind of push down a little bit right on these little teeth here, but try not to damage them. Not a huge deal if you do. It's just they're really messy and they kind of get everywhere. So if you hear that crack, and then basically it just split the shell, and then sometimes you can use just like a regular little trim tool to kind of help yourself out. There we go. And this is all I have, is just this tiny little trim tool. Something like this works really nice, because then you can squeeze it into the side here, and you don't run the risk of damaging a battery or anything like that. And then the clam shell comes off. So it seems like a lot of work. That one actually was a lot harder because I was trying to explain it and not screw anything up of all of these, and otherwise I'm done processing and shucking all these. So it doesn't take very long once you set up a little process and kind of just get going and get into your groove, you can kind of crack one. Boom. That one's all cracked up. And one of these sides is easier than the other to get off. If you're looking at it like this, the right side's always easier to get off because it's taped. The left side is much harder, and you do need the trim tool for it. So I flip it back over so you can see the side with the double label. Just put the trim tool between the battery and the case right here on that side, and you can bend the case out a lot, and then you just kind of just pry and flick the battery right out. It comes out super easy. And the nice part is it leaves a lot of that rubberized plastic crap in here, or a good chunk of it. I mean, there's still a lot on the batteries, but not too bad. All right, and then once you get them stripped apart, they kind of look like this. It's 4 cells. Got your BMS. There's 4 wires. And so basically the way I attack these is I go after, and I just use my pliers, just pull the wires off. I go white, yellow, red, black, just because I can. Oh, don't actually throw those away. I save those for so I can put them in e-waste. And then so you can just pull these apart, and then you just kind of give these just a little twist. They all kind of come apart into a chain of 4, and then you just kind of give them a pull. They'll break into a nice long 4-piece chain, and then I basically just start at the top and just pull off the tape and all the extra junk and toss that, and I got a trash can right below me, and then just take my pliers and just slowly pry this stuff up, the little nickel metal strip stuff here, and toss it into the bin. And then you kind of just work your way. And so that's one separated, and then kind of just pull a lot of this stuff off. You just kind of got to do a pull, wiggle, and it all comes up pretty easy. Almost there. There's another one. All right, and then that's the last one. So I mean, it does take a a little bit of time, 2-3 minutes per battery. But then, I mean, they do get left with, kind of some stuff on the nipples, and even the flats. So you need to clean these off. Probably a little sandpaper or something like that to knock them off, or side cutters. Some can be kind of gnarly. So you gotta watch out for those, because that sucker will cut you. I've been cut here. I took a gouge of the thumb. They're really thin and they hurt way more than a paper cut. But yeah, and so you kind of just bust them apart, and then a little BMS. I just got a bag of all the e-waste. So that's what I've been doing. Catch up with you in a second here when I've got these all done, and I'm off to, cleaning off all of this stuff. All right, guys. So thanks for watching me take apart some of those battery packs. I've got most of them kind of stripped down now. As you saw in the last clip, I was pulling off all the tabs and stuff like that off of them. And what I found that works the best is actually one of these little cheap side cutters. They're only a couple of bucks. But these work really, really nice because you're able to get in there and practically pull the pieces right off. So totally recommend these. They're like $3 on Amazon. So not a bad piece to pick up. As you can see kind of behind me, it's all running, and currently they're on the testers. I've got all the 2600 milliamp hours done. And so I'm processing all the 2200 milliamp hour stuff right now currently. I've got about 140 or so, give or take, maybe 150 of the 2600 milliamp hour one. So plan on making a pretty big pack out of those. I did check. They are like 6 or 10 amp. I wrote it all down. I think they're like 10 amp peak, 6 amp continuous on all those batteries. So I could be wrong, but they look pretty decent. So if I throw them in a big enough pack, they should be able to handle an okay load. I mean, if I plan on doing anything too crazy, I'll definitely find other ones. I found these ones local really cheap and just kind of wanted to play around. And tomorrow I do actually have a couple of surprises coming. But the first one it's called a K-weld. And it's basically a battery spot welder. Well, I already have one. I have a Sunco, which is like a Chinese unit. It's not bad, but they're a little hard to start to do some of the wider packs on. You can only get about 3-4 rows on them before they start getting a little weird, and you have to start building them in sections at a time, and then build the packs around that. So I did get a K-weld, and I got a K-cap, which is the kind of the power supply for it. So, well, you still need a power supply, but you don't need something that can handle like 150C, so it doesn't have to take like a 1500 amp short, 1,000 times, which would definitely destroy most power supplies. So it's pretty sweet with these. It's a 2S3P super capacitor setup that feeds this thing. So it's really awesome. It's also not supposed to pop your circuit breakers quite like some of the Chinese units, because unfortunately with the Chinese units, they do have decent power, but the inrush current is crazy because they do only have a single step-up transformer. So when you plug these things in, a lot of times what people will do is they'll plug them in, turn them on, their breaker will trip, they will go downstairs, leave them all turned on, and then go downstairs and flip the breaker on because the inrush current is so strong on these. So kind of sketchy, and that's why I went with something like a K-weld. You can also people do it with just car batteries and starter relays or contactors. you can do it, but I mean, if that battery is 1,000 amps shorted, you're shorting a battery, sitting right next to you. And, because the problem is for spot welding, your leads are like this. It's pretty crazy. Like the difference of 6 inches can mean for the amount of joules that you're able to actually pass through. And so some of this stuff that I've seen for people's homemade ones were definitely a little scary, or were involved tearing apart a microwave. I don't know. That's a little past what I'm willing to do. I'll spend a little bit more and get something that's kind of tried, true, and dependable. So that's what I got going. And then also coming tomorrow, they kind of all just stacking up. I do have an Ender 3 Pro, a Creality Ender 3 Pro 3D printer on the way. And that's what's in this box is one of the many spools of PLA that I ordered for this. So going to be making all sorts of cool little things with this, putting it up on the channel. Would love to build car parts and all sorts of stuff. Probably looking at picking up some TPU or some sort of flexible filaments. Try making maybe cup holder inserts. I don't know. All sorts of cool stuff for my car and trucks and stuff. So I don't know. Definitely check it out. If you guys like this stuff, please like, share, subscribe, and leave a comment. Let me know. Again, I know it's not our normal car stuff. And that should be returning, hopefully. But yeah, in the time being, I hope you like it.